Nitrogen dioxide is the chemical compound with the formula NO2. It is one of several nitrogen oxides. NO2 is an intermediate in the industrial synthesis of nitric acid, millions of tons of which are produced each year. This reddish-brown toxic gas has a characteristic sharp, biting odor and is a prominent air pollutant. Nitrogen dioxide is a paramagnetic, bent molecule with C2V point group symmetry. Molecular properties: nitrogen dioxide is a molar mass of 46.0055, which makes it heavier than air, whose average molar mass is 28.8. The bond length between the nitrogen atom and the oxygen atom is 119.7 pm. This bond length is consistent with a bond order between 1 and 2. Unlike ozone, O3, the ground electronic state of nitrogen dioxide is a doublet state, since nitrogen has one unpaired electron, which decreases the alpha effect compared to nitrite and creates a weak bonding interaction with the oxygen lone pairs. The lone electron in NO2 also means that this compound is a free radical. Preparation and reactions: nitrogen dioxide typically arises via the oxidation of nitric oxide by oxygen in air, 2NO plus O, 2A2NO2. In the laboratory, NO2 can be prepared in a two-step procedure where dehydration of nitric acid produces dinitrogen pentoxide, which subsequently undergoes thermal decomposition, 2HNO, 3N, 2O, 5 plus H, 2O, 2N, 2O, 5A4NO, 2 plus O, 2. The thermal decomposition of some metal nitrates also affords NO2, 2Pb, NO3, 2A2PbO plus 4NO, 2 plus O2. Alternatively, reduction of concentrated nitric acid by metal. 4HNO, 3 plus cubic ACU, NO3, 2 plus 2NO, 2 plus 2 hours 2O, or finally by adding concentrated nitric acid over tin. Stannic acid is produced as byproduct. 4HNO3 plus SNH2O plus H2SNO3 plus 4NO2, main reactions, basic thermal properties: NO2 exists in equilibrium with the colorless gas dinitrogen tetroxide, N2O, 4, 2NO, 2N, 2O, 4. The equilibrium is characterized by IH equals a 57.23 kJ per mole, which is exothermic. NO2 is favored at higher temperatures, while at lower temperatures, dinitrogen tetroxide predominates. Dinitrogen tetroxide, N2O, 4, can be obtained as a white solid with melting point to 11.2 AA degrees Celsius. NO2 is paramagnetic due to its unpaired electron, while N2O4 is diamagnetic. The chemistry of nitrogen dioxide has been investigated extensively. At 150 AA degrees Celsius, NO2 decomposes with release of oxygen via an endothermic process, 2NO, 2A2NO plus O2, as an oxidizer, as suggested by the weakness of the Na-O bond. NO2 is a good oxidizer. Consequently, it will combust, sometimes explosively, with many compounds, such as hydrocarbons. Hydrolysis: it hydrolyzes to give nitric acid and nitrous acid, 2NO, 2 per Newton, 2O, 4 plus H, 2OHNO, 2 plus HNO, 3. This reaction is one step in the Ostwald process for the industrial production of nitric acid from ammonia. Nitric acid decomposes slowly to nitrogen dioxide, which confers the characteristic yellow color of most samples of this acid, 4HNO, 3A4NO, 2 plus 2 hours, 2O plus O2. Conversion to nitrates: NO2 is used to generate anhydrous metal nitrates from the oxides, MO plus 3NO, 2AM, NO3, 2 plus NO. Alkyl and metal iodides give the corresponding nitrites, 2CH, 3I plus 2NO, 2A2CH, 3NO, 2 plus I, 2, Ti, 4 plus 4NO, 2A NO, 2, 4 plus 2I. 2. Safety and pollution considerations: nitrogen dioxide is toxic by inhalation. However, as the compound is acrid and easily detectable by smell at low concentrations, Inhalation exposure can generally be avoided. One potential source of exposure is white fuming nitric acid, which spontaneously produces NO2 above 0 AA degrees Celsius. Symptoms of poisoning tend to appear several hours after inhalation of a low but potentially fatal dose. Also, low concentrations will anesthetize the nose, thus creating a potential for overexposure. There is some evidence that long-term exposure to NO2 at concentrations above 40/100 AA microgram M3 may decrease lung function and increase the risk of respiratory symptoms. Nitrogen dioxide is formed in most combustion processes using air as the oxidant. At elevated temperatures, nitrogen combines with oxygen to form nitric oxide, O2 plus N2O2NO. Nitric oxide can be oxidized in air to form nitrogen dioxide. At normal atmospheric concentrations, this is a very slow process. 2NO plus O2O2NO2, the most prominent sources of NO2 are internal combustion engines, thermal power stations and, to a lesser extent, pulp mills. Butane gas heaters and stoves are also sources. The excess air required for complete combustion of fuels in these processes introduces nitrogen into the combustion reactions at high temperatures and produces nitrogen oxides. Limiting NOx production demands the precise control of the amount of air used in combustion. In households, kerosene heaters and gas heaters are sources of nitrogen dioxide. Nitrogen dioxide is also produced by atmospheric nuclear tests, and is responsible for the reddish color of mushroom clouds. Nitrogen dioxide is a large-scale pollutant, with rural background ground-level concentrations in some areas around 30 AA microgram M3, not far below unhealthy levels. Nitrogen dioxide plays a role in atmospheric chemistry, including the formation of tropospheric ozone. A 2005 study by researchers at the University of California, San Diego, suggests a link between NO2 levels and sudden infant death syndrome. Nitrogen dioxide is also produced naturally during electrical storms. The term for this process is atmospheric fixation of nitrogen. The rain produced during such storms is especially good for the garden as it contains trace amounts of fertilizer. See also: nitrite, dinitrogen tetroxide, nitrile, nitrous oxide, N2O, laughing gas, a linear molecule, isoelectronic with CO2 but with a non-symmetric arrangement of atoms, nitric oxide, a problematic pollutant that is short-lived because it converts to NO2 in the presence of free oxygen. External links: International Chemical Safety Card 0930, National Pollutant Inventory, Oxides of Nitrogen Fact Sheet, NIOSH Pocket Guide to Chemical Hazards, WHO Europe Reports, Health Aspects of Air Pollution and Answer to Follow-up Questions from CAFE, Nitrogen Dioxide Air Pollution, Nitrogen Dioxide Pollution in the World, a review of the acute and long-term impacts of exposure to nitrogen dioxide in the United Kingdom IOM Research Report TM03, references.